several options here. We have the i5 650, which is the base model, and then we have the V6, and then we have the V8, and the V8 with a turbo. Okay, so what are these numbers exactly? I mean, because Dell would not display something unless it is relevant, okay? Because otherwise they would just be throwing technical terms on the screen that most people would just ignore. Okay, the first part has to do with the Intel Core i. Okay, the Intel Core i is an entire family of processors. Okay, the previous generation is called the Core 2, and now the current generation is called the Core i. The number i5, i7, and so on and so forth, you can look at this kind of like a model number. Okay, the i5 and i3s use one particular socket configuration. The i7 has a different socket configuration. It has more pins than the i5. But since you're not putting the system together, that part is, for the most part, irrelevant. The sub number here, the 650 versus the 760, it deals with minor differences along the same model line. Like in this case, one has the less expensive one has 4 megabytes of cache. The more expensive one has 8 megabytes of cache. Now we're starting to get into terms where an explanation would be appropriate. What exactly is a cache, and why is it necessary? Why do we want more cache whenever we specify a processor? It has to do with the speed discrepancy between the memory bus and also the processing speed. Okay? Most processors, you can see that it runs at a particular gigahertz or frequency. 3.2 gigahertz means there are 3.2 billions of cycles per second. And most processors now can execute one instruction per cycle, and you have at least 2 or 4 cores for each processor. So we are talking about a lot of processing resources here. We can do a lot of calculations. The question is, can you keep the processor fed all the time? Can you give the processor enough data to process all the time? That's the question. Because memory is slow, but the processor is a lot faster than memory. It's kind of like, how fast can you guys read? How many pages per minute, on a regular type of book like this book here? I'm guessing maybe 2 minutes per page, kind of conservative, okay? Okay, so let's just say it is 2 minutes per page. That's your speed of reading. Okay, you can process information at 2 minutes per page. But let's also say that you don't have a book anymore. Okay, the book is being delivered to you page by page. Okay, you have to get someone to get the next page, and then the next page, and then the next page. And also, let's just say that the actual book is in the library somewhere. Okay. So now, how fast we can read is not really limited by how fast you can read. It is limited by how fast that somebody can deliver the next page for you to read. Okay? Now, it's a question of, are we talking about a library that is right here? Maybe someone can get over there and come back with a new page every 5 minutes or so. Okay? Which is already slow because you can read, more than 2 pages in 5 minutes. But what if we're talking about the county library? Then we are talking about, 15 minutes of round-trip time? Then it becomes really slow. Okay? Are we getting the picture here of, how the memory, being the library, is really slow compared to the processor, which is you reading, the pages? Okay? Is that working out so far? And the order of magnitude is really about that bad. Okay, we are talking about easily 8 to 1. Okay, in terms of how fast content can be delivered to the processor for processing, as opposed to the processing speed of the processor. It is about 8 to 1. So that's exactly why we have caches on these processors. Caches are basically local copies of pages. Okay? Every time you say, oh, I'm running out of material to read, you're not asking that someone to go to the county library to send back exactly just 1 page. You're asking that person to make a copy of 16 pages at a time. Okay? The 16 pages that person brings back is quote-unquote the cache. The cache is limiting how many pages can you keep in the classroom at any particular time. If you can keep 64 pages, that means that person can go even further or be slower, and you can still have enough material to read when you're in the room. If you have a cache of only 2 pages, then you can run out of material to read really quickly if that person takes too long to go to the library to fetch the next 2 pages. Are we getting the idea here? And that's why the more cache, the better, because it means that the processor can keep more stuff locally to the processor, and the cache for the most part can keep up with the processing speed. Not exactly the same, but pretty close. Okay, pretty close. So are we good? Yep, go ahead.
So the less gigahertz, the better.
The gigahertz is interesting. This is actually the internal clock speed of the processor. So typically you would say the faster the processor, the better, because that basically is how fast you can read. But in this case, you can see that the cache size has twice the cache size. So sometimes it is entirely possible that this one would actually go faster. It also depends on the number of cores. The i5-650, I know for sure, is a dual-core processor. It only has 2 processor cores. The 760, I think, is a quad-core processor. So if you look at it that way, that means with the i5-650, only 2 processors can work on stuff at the same time. But with the i5-760, up to 4 cores can work on stuff at the same time. Now, does that guarantee that the quad-core processor will always win? It is not always the case, because it depends on what you are doing. If you're running programs that do not exploit the fact that you have multiple cores or multiple processors, then having 4 cores is useless. Okay? Because your operating system, if it does not know how to make use of the extra processing resources, will only use 1 core at a time, and it boils down to exactly the same thing as a single core processor. Yep.
So it's the operating system that decides that?
The operating system is one factor, but for the most part, it is your application. Certain applications, we can easily use multiple cores, and other applications cannot easily use multiple cores. Yep.
How many applications actually do use multiple cores?
Rendering software for one will use multiple core. Transcoders will also use multiple cores whenever it is available. Encryption cracking software obviously can use multiple core as well. Most games now, also use multiple cores whenever they are available. But your typical word processing software or Excel spreadsheets, that sort of thing, I do not think they are aware of multiple cores. So it's up to the operating system and say, oh, that process is busy doing virus checking, so I will divert the spreadsheet calculation task to this one instead.
So if applications don't take specific use of multiple cores, the operating system has to take over.
Right, but then it depends on what applications you're running, because if all you're doing is typing, like an English paper, then nothing is really going on. You can live with just 1 core just as easily in that case. So having a multi-core setup does not really help in that case.
The typical user will never access the multiple cores.
A dual core will still be useful. There are certain things that the system has to do in the background when you are typing your English paper. The system will still be, checking the viruses, checking for updates and so on and so forth. So a dual core processor will always, help. It will always be faster, or at least feel faster than a single core processor. But beyond a dual core, then it depends heavily on what you're doing with your computer. To go from a dual core to a quad core, to go from 2 to 4, it depends on what you're doing. Yep.
Two questions. If an application is only going to take 1 core, but then you start running a bunch of applications and set the affinities to the different cores, will that do it? You know what I mean? Will that help things go faster in the long run? The application itself can only use 1 core, but then you're saying, okay, use this core, and then you're going to another program and you're saying, okay, this application, use that core.
Yep.
If you go
the operating system would do that.
Sometimes they'll fight.
Sometimes they want to use the same resource in terms of the hard drive or the screen or the mouse or something like that. Then they have to line up and say, okay, who gets to go first? So whenever you have I/O operation or input-output operations, then the number of cores does not matter anymore because now the speed is completely limited by the I/O devices. Like going out, on the network card is very slow. So if you're already bound by network traffic or network bandwidth, then it doesn't matter. You can use a very weak processor and still saturate the pipe, especially when you have a slow connection to the internet.
Why is the 880 not have cache size?
The 880, why does it not have any cache size specification? I do not know. I think it probably has the same as the 870.
Well, there's just a huge jump,
in terms of
150 to
price?
500, yeah.
That is true. Yep, it is entirely a different class. You add $500, to add that part here. Now, if you're interested, I think you can look it up, like i7 880, and this is so it has 8 megabytes of smart cache. Sorry? The question is, how many cores do we have? Okay, let's see, specification. It's a 4-core, 8-thread type of model. So I think it is almost exactly the same as the 870, except the top end speed is a little bit faster.
So what's the point of making it more than twice that?
Oh, they do it all the time. With the pricing of processors, has nothing to do with how much it costs to manufacture the part. It has to do with how much people are willing to pay for that one little bit of extra speed. So you're better off, with the low to medium low end of processors. They usually are at a very good price point, performance to price ratio. As soon as you get into the quote unquote high end or high performance type of processors, you have to pay a lot more to get the one little bit of jump. So do we have any questions about processors? You can also click Help Me Choose. And Dell has its own little educational material to talk about processors. Are we okay so far? Okay. Now, when you're talking about the laptop computer, some of these options are not available or is not a viable option. Like the i7 880 with a quad-core processor running at 3.06 gigahertz will be too much power. In other words, one, the battery won't last very long. And two, it will generate too much heat. But you can say, but we can throttle it down and not use as much of the processing power. Then why bother with the i7 880? You can just go walk away with an i5 processor, and it will cost far less than the i7 880 processor. All the lab machines that we have in room 152, they only have i3 processors, which is not even on the list here. So they are basically a lower end type of processor. But once again, in the case of a lab, the discount is very important because if we can save, say, $50 per machine, it all adds up. Originally, the lab actually wanted to specify i5 processors, but they found that with the i5 configuration, we could not replace all the computers in all the labs. Once they switched to an i3 processor, which is almost the same as an i5 minus a few features, they were able to replace all the computers. So that's why, when you're talking about an institution, the criteria of choosing a computer is different because $50 may not seem a lot when you're buying a single computer, but when you're buying like 50, 100 or more computers, $50 can add up. You can buy some extra computers with that $50. Okay. Well, we have about a minute left, so we'll just go ahead and move on a little bit because I want to kind of keep moving. Okay, now you can select your operating system. This part annoys me to no end. There's no option of no operating system. Okay, in other words,